Let's go over some basics of databases. I show here some sample data from a cable TV company. Within large companies, there's typically multiple departments. So we have some data that's used by the billing department and some additional data that's used by the service department. In the billing department, they have an account table. There's an account ID, first name, middle initial, last name, address, etc. associated with the account. There's a billing table. Each bill has a unique billing number, a billing date, the amount, and which account is being billed. And there's a payment table. The payment is related back to the bill. The bill could be paid in multiple payments, as in the first two lines here. There's a payment date and a payment amount. In the service department, they likewise need to have the account information. There's also a service table with a service ID, the date of the service code, which tells us what type of service is being done, and the account that it's being done for. And then there's a service code table that describes the type of service and whether that service is billable or not. The first important term is a row in a table is called a tuple. A column in a table is called an attribute. Sometimes different terms are used to mean the same thing. As I mentioned, a column is called an attribute. It might also be called a field. A row is called a tuple. It might also be called a record, like an account record, for instance. And a table might also be called a file. A database is a collection of interrelated tables. All of the tables in the database need to be related to at least something else in the database, or else the table doesn't belong. A database management system is the software, like MySQL, that manages the data in the database. One of the requirements in database systems is that every row in every table has to be uniquely identified. The primary key is one or more attributes to uniquely identify each row. So in the account table, it's the account ID. In the billing table, it's the billing ID. In the payment table, because we might have more than one payment associated with a bill, the unique identifier is the combination of billing ID and payment number. So you can see in the first two rows, there are two payments associated with the same bill. In the service department, the account ID uniquely identifies each row or each record or tuple in the account table. The service ID is the unique identifier for the service table, and the service code is the unique identifier for the service code table. Another principle of databases is that all of the non-key attributes, the items that aren't circled in this example, have to be related to the primary key. For instance, everything in the account table is related to the account ID. Everything in the billing table is related to a specific bill. All data for a particular attribute should be in the same format. So in this case, the zip code should be a 5-digit zip code. Only one piece of data can be stored in each cell. So for instance, because two payments were made for bill 2328, we need to store those payments in different rows. And so we assign an additional identifier, the payment number, so that the combination of billing ID and payment number uniquely identifies each row. Within a table, every attribute has a unique name. Two different tables, however, could have the same attribute name. In this example, the billing table has a column called amount, and the payment table has a column called amount. Because amount is in different tables, it has different meanings. In the billing table, amount means the amount that was billed, and in the payment table, it means the amount that was paid. In order to relate two tables together, a foreign key is a column in one table that matches the primary key in another table. So in the billing table, there's an account ID that matches the primary key account ID in the account table. In the payment table, there's a billing ID that matches back to the billing ID in the billing table. Likewise, in the service department, the service table has an account ID to match back to the account table. The service code in the service table matches the service code in the service code table. When two tables are related, one of the tables, not both, needs a foreign key to link to the other table. And once again, a foreign key is a column in one table that links to the primary key in another table. Now, one of the problems with this example is that both the billing and the service departments have their own account tables. The problem is, if data is updated in one, like a new address because the person moved, it might not get updated in both places. So one of the other principles as we're putting together databases is that we only want to have data stored in one place in the database. We don't want to have duplicate data. So to avoid a problem with data being updated in one place and not in the other, what we want to do is combine the data so that none of it is duplicated. To have one account table, for instance, that's used by both the service department and the billing department. All of the non-key data is stored only once in this example, and that's what we want to have. Now, when we talk about the key data, because a foreign key in one table is used to match to the primary key in another table, like the account ID, that piece of data is stored twice. But typically, because the account ID is never updated, this doesn't present us a problem. And so when I say the account ID is stored twice, what I mean is it's stored once in the billing table in order to match to the account table. It's stored again in the service table in order to match back to the account table. So this diagrams what file-based systems would look like. Typically, the billing department and service department would have their own systems, and maybe we also have a marketing department that has its own systems. And in file-based setups, each system has its own sets of files. So we see there's an account file for the billing department, the service department, and the marketing department. And because information is duplicated in 2 or 3 different account files, there's the probability that as data is updated, it's not going to get updated in each of the individual files. So what we want to do instead of this is we want to have a database system where we have shared data, and each piece of data, unless it's the primary and foreign keys, are stored only once in the database. So in this example, we only have one account table that's shared among the billing system, the service system, and the marketing system. The principle of storing data only once in our database is key to how database systems work.